Hello everyone, I'm Dylan the math tutor, and today I'll be explaining how to use substitution for integration. Sub is another one of the first and most useful integration techniques in calculus. It goes something like this. When we encounter an integral in this form, where we have two functions kind of multiplied together, but we have a similarity in this g of x and this g prime of x. G prime of x is the derivative of g of x, but it's inside of our f of x function. Now this may look a little confusing, but I'll explain using an example. X e to the x squared. Okay, so in this case, we have two functions of x multiplied together, but this function has e to the x squared, as an x squared inside. Now normally, when we encounter an e to the x, that just equals e to the x, right? Very simple, plus c. But we can't say the same for this case. We're not sure what the integral of e to the x squared is. But we can use the technique called sub by substituting this inside function for u. Okay, so we're going to say u equals x squared. We take the derivative of x squared and u. We're going to get du equals 2x dx. Okay, now how is this useful? Well, we can put this integral into terms of u to make it simpler to solve. How do we do that? Well, if you notice this u here, we can replace this x squared with u, and we can replace this x dx with du. One small thing, we have this 2 in front, so we just need to bring it over to the other side by saying that 1/2 du equals x dx. Okay. If we replace x dx here with 1/2 du, we can rewrite this integral in terms of u. So let's do that. We have e to the power of u, and then we have times 1/2 du, which is replacing our x dx. Okay. Now let me simplify. So since this is a coefficient, we can bring it out front. Then we're left with e to the u du. Okay. Now this we know how to do. This is going to equal, I'll do it over here. This is going to be 1/2 e to the u plus c. Cool. Now we integrated, right, from here to here. Now let's put this back into terms of x using these equations up here. So we see that u equals x squared. We can plug that back into here and say that this is equal to 1/2 e to the x squared plus c. And there's our answer. Okay, fairly straightforward, but we have this, some weird steps here. So I'll give you a practice problem to do, and then I'll reveal the answer. Let's try x cosine of x squared dx. Okay, so try this on your own. When you get stuck, unpause the video, come back. Okay, hopefully you tried it Now, let's look. Immediately I see that this inside here is going to be our u, and then this dx and x is going to be our du. How I know this is because if we take this x squared as our u, when we take the derivative, we're getting our x dx. Now, similar to the last one, we have to bring the 1/2 over. But what we're left with is x dx. Now let's replace it. So let's substitute the u in. So we're going to get cosine of u times 1/2 du. All right, let's simplify. 1/2 cosine of u du. Now, the integral of cosine of u du is just sine of u plus c. Now, let's put it back in terms of x, substituting in x squared for u. This is going to equal 1/2 sine of x squared plus c. All right. This is our final answer. Hope you got that. All right. Thank you so much for watching. If you enjoyed this video, please hit that like and subscribe button. Leave a comment below of what topic you'd like to see next. All right. Take care. Have a good day.